Hello, everyone, and welcome to today's deep dive webinar, Is This a Good Model? My name is Alex Zyko. I'm here with James Cousins. James is a senior statistical analyst here at the company. And today we're going to be focusing on our statistical modeling and exploration product, Vera Predict. We'll be using Vera Predict to unpack the validation statistics used when crafting a model to identify the goodness of fit. So some key points that we're going to cover are the decile analysis, the walled chi-squares, concordance rates, among other things. But before we get to the main presentation, I want to quickly review other resources available to master the Rapid Insight software platform. And then after the presentation, we're going to field some questions about the topics that James has covered. First, we have, here we are, previous deep dive webinars on demand. Some of those are Vera Construct tips and tricks, as well as subroutines, easier than hard coding. Subroutines are a popular feature in Vera Construct that require a little bit more explanation. As well as an upcoming webinar, 5 critical factors for your prospect enrollment modeling. This is a presentation that's targeted toward higher education institutional research professionals. Secondly, we have other self-serve resources for our products, Vera Construct and Vera Predict. They are training videos that highlight key features, as well as an online help manual with search features, visual descriptions, and video links. So all of these can be found at our website. And next, we also have, again, targeted for our higher ed enrollment professionals, we have a detailed enrollment management series. This is titled A Day in the Life Enrollment Management. And in this video series, James walks through the steps of building out a Vera Construct job using enrollment management as a framework. And then lastly, we have our in-person resources of our staff of analysts. We are the direct line over the phone and behind the support emails, answering all sorts of questions about our products and helping them work for you and your tasks. And speaking of our products, to quickly review what they are, there is Vera Construct. That's our self-serve data prep tool. Vera Predict is our predictive modeling and statistical exploration tool, and Vera Bridge is our cloud-based data sharing platform. Now, all of these products can work both independently of each other as well as dovetailed together to support every step of the data analysis that you might require. And with that being said, I'm going to invite James to come on in and take it away and get things started with Vera Deep Dive. Is this a good model? James?
Thank you, Alex. And thank you, everybody, for taking time out of your day to join me and Alex today. We're obviously going to be talking about how to identify a good model and somewhat logically how to move from identifying the goodness of a model to how you might adjust it or correct it or improve it. So we'll be talking a little bit about that as well. As I go through, however, this is the nature of this entire webinar series is one that is rooted in the questions that we receive from customers on a daily basis. And so we are definitely interested in making these also very question driven. So as we go through, if you do notice there is a questions pane inside of the webinar toolbar, you should all have access to that. And if you do have questions throughout the process, both myself and Alex will try to keep an eye on it. We'll definitely field them at the end, but if we happen to catch them throughout, then we might be able to field those as we go through. So definitely, if you see something that you're curious about, ask about it. We'll talk about it here today. So those questions, I'm going to offer up some to begin with so that you know what to be asking. First of all, I think it's important to note how simple life can be if you just ask yourself, is this a good model? And if it is, then congratulations. If it's not, then you do something and then you have a good model. So congratulations, you win in either scenario, which is the good news. But we're going to obviously be talking about the question marks there. So the first question I think is really important before you even start looking at the software, or potentially even before you begin modeling, is to know exactly what your intended takeaways are. Why are you actually building models, which is not some sort of highly intellectual pursuit of knowledge for the sake of itself. It helps you understand what you need to do. So if you just want to perform exploratory analysis and you're hoping to get predictions out of it, but really the main highlight is the fact that you'll start to understand what characteristics are related to your outcomes, then that gives you definitely a focus that doesn't need to go quite as far as investigating finer points of the model diagnostics, as an example. And in the same light, overall forecast versus target identification, or possibly in addition to target identification. Sometimes your model is meant to give you a picture of how things are going to shape up in the big picture. So for instance, some examples would be understanding how many students overall will return next fall or next spring, how many students will graduate on time, and then on the enrollment side, how many of your prospects will send in applications. Those bigger picture questions actually are kind of forgiving as far as individual predictions, because you might look at somebody, a prospect or an enrollee, or even a potential donor somewhere else in the pipeline. You might look at them and say they're quite likely to achieve a certain outcome, and they might not actually achieve that outcome. And that's okay for an overall forecast, because it kind of might shake out in the grand scheme, but it's less okay if your goal is target identification or actual preemptive action and driving some of those outcomes via outreach. So it's important to know which you're pursuing, or if you're pursuing all three, which is the emphasis, because once you have an idea of that, then it really fills in some of the blanks of how far you need to go with the next steps. And that is pretty related to the next point here, and apologies for, I probably should have added in some cool animations and more pictures than just this bad joke, but the next question is, what calls to action are actually expected from your model? Because that also gives you an idea. You might need to ask certain questions if you know that these results are going to be passed along to a certain audience. There are, just to get an example here, there are sometimes sensitive variables that might be informative, but if you're actually going to perform some sort of action based on the model, you might not want that variable to actually be the basis for any decisions or actions that you take. Some examples might be, as an example, there are demographic fields, there are socioeconomic status fields, and there are some circumstances where you might ethically just be concerned about, are we actually going to target this person simply because they have a lower income? And sometimes the answer is going to be yes, and then other times the answer might be no. For instance, if it's a religion variable or if it's a ethnicity variable. So these are all questions to ask. And then as far as actually starting to answer them or use them during the process of evaluating your model, there are a couple of points that I wanted to bring up. Now, as a heads up, this presentation is not going to be entirely slide-based. So I realize I never made any mention of that, but I'm definitely going to walk through the software and actually show you and even ask you at points in time what stands out to you, or point out some things within the context of actually using the tool. So, stick with me through these slides, especially if these aren't your preferred way to learn this content. So there are three basic areas when you're actually building the model specifically inside of Vera Predict. And I think most people are probably familiar with this, but this already can give you a sense, each of these can provide a specific answer when you're trying to figure out if the model is good or not. So at the stage that you build the model, some variables will shift over to the included side and some will stay in the non-included side, but the related side and off the left. Now, when this happens, this might be an obvious cue, because if you see something included in the model that you as the subject matter expert know is not a valid predictor or indicates to you that there is more data prep needed, that's one of the first places that I advocate for people to explore what the model is actually saying. There is also the numeric diagnostics, and I will admit that this is something that is much more granular. I'm going to be focusing on the actual day-to-day takeaways that you can find from this pane, so I'm not going to necessarily cover the exact definition of a t-value or a p-value, but I will explain what that means for you as you're trying to build a better model. And then finally, the visual diagnostics. I wanted to cover this very specifically because I think that it is such a useful way to explore the results. And when I say that, the decile analysis, it's the most immediate visual confirmation of how your model is performing. So taking a look here, these roughly cover maybe the four. There might be other common examples, but these roughly cover the four possibilities for your deciles. And so just as a reference, oh gosh, you know what I forgot to point out was, well, I'll get to that. So stay tuned, there's exciting stuff coming. So as you go through, you might see this decile analysis when you build your model. This, not to say that it's impossible that it could provide value, but it's not a good model, I would feel pretty comfortable saying that. And the reason that I say that is because if you look at this decile, the first group is really not any more likely to achieve your outcome, or it doesn't have necessarily a higher score than essentially any other decile. It seems to be entirely random, and there's not actually much systematic accuracy occurring in this. Unlike this model towards the top right, so this is essentially the ideal. If you ever see this, then that's a really great sign, and you don't necessarily want to stop investigating, but this definitely would reassure me that I can expect a good model out of the process. This model, when I say that this is a class of decile analyses, what I mean is that there is this first decile that is definitely a concentration of the higher score, or the higher likelihood, and then the rest, it's not necessarily doing a great job of parsing out. So you see here, this group is supposed to be more likely than all of the ones after it, but actually it's not true at all. There are plenty of deciles that have higher rates. Hopefully this is all making sense. But it's great for target identification. I mentioned that sometimes you're concerned about overall accuracy, and sometimes you're concerned about finding a group of people to look at or to reach out to. This is still a pretty good model for that purpose, because if you have the resources to try and intervene or reach out to 10% of your population, you can be pretty confident this is going to give you the right group of people to reach out to. And then this analysis I pull up, again, trying to keep it focused or working towards the software side of things, but this is kind of interesting because it happens a lot, and it often occurs when there is some binary that is really predictive. And so it's basically saying, you can kind of imagine it as a light switch, but people that are in one category all behave at sort of higher rates or achieve higher scores, and then everybody who's not is kind of in the same boat as each other as well. So this is kind of simplistic, but it does also reveal information. So I'd say all of these three towards the right and the bottom, these are good starts, whereas this one kind of would indicate that it's going to be a longer process ultimately. Now, I can come back to this. Please toss in a question on the pane if you want me to go back to this and review it in detail. But I would like to talk through it as well during the actual software walkthrough. This is mostly for reference. This just details how the decile analyses actually come about, and probably should have placed that before the actual discussion of the decile analyses, thinking about it a second time here, but that's okay. I want to come I want to come back to this list at the end because I think it's a great concentrated list. I asked some of the other workers here at the office what they would add to it, and all of these are great signs. They're bad signs, I should say, actually. They're bad signs, but they are great indicators that your model is not good. So these are the things that when I typically start working with a customer, I see them and they kind of jump out at me as things that need to be handled. Anachronistic variables, it's a polysyllabic word, but all it means is that sometimes there are variables that occur after the point in time that you're hoping to score. So I probably should have added a poll for this, but if anybody has ever been in the position where they're trying to predict first year to second year retention, as an example, and then they discover that a flag for a second year seminar course enters their model, that's a great example of an anachronistic variable. You won't know if they're going to take that course until they've actually made it to their second year. And so your model is not good in the sense that it might be very accurate, except that it's not going to actually be applicable at the time that you hope to then score people. So again, hopefully that makes sense, and ask me a question about it if you want me to review that again. Surrogate variables, these are variables that stand in for one another, and it happens also much more frequently than you would expect. And so, for instance, I was asking around, and one of the examples that was provided was that a scholarship code, this was a coworker of mine, John, he was working with the data set, and there was a scholarship code that was only applicable to people who had gotten far enough in the pipeline that they were essentially going to enroll. And so that was entering as a predictor of enrollment, but at that point, it actually is kind of identical to enrollment, that it indicates or stands in for the actual enrollment flag. And so that's something to keep an eye out for. Heterogeneous modeling populations, I'm actually going to hold off. I'm going to cover that within one of the examples in a moment here. Insufficient variables. A lot of times people go into the modeling process and they say, they try to limit the amount of characteristics that go into their analysis on the thought that it takes extra time to review extra variables. But typically speaking, more variables don't actually add too much time to the process, and it typically can only help you because there are things that you might not think would be predictive, but that they actually are. And then I'll also talk about subject matter expertise, I think, inside of the actual demonstration. And we really don't need to get into that there, but it's in there for reference, and we'll definitely cover that. So I'm going to switch over to the software now, but before I do, I'll remind everybody that you can definitely be asking questions, but I do want to point out, it's perhaps a little bit after the fact, but if you go to this link, if you go back to our website and the webinar page, you can actually download every one of the analysis files that I'm using in today's webinar. So we're going to be covering one example of cab fare prediction, one example of loan default, student loan default, and then another one of enrollment modeling. So that is available to you. You can go to that and explore those. They might not finish in time for you to play along, but you're definitely encouraged to explore those. And with that, I will switch over to the software. Yeah, okay. So I think everybody's familiar with the Vera Predict. And then here, what I'm able to do is, obviously I can open a file or load a saved analysis. I've already done that, and I have these queued up because I wanted to make sure that we all had time to focus on as many use cases as possible. So just sort of picking one at random, we'll go with the loan default first. And so this model, I'll go straight to the modeling process and I'll build automatically. For those that haven't heard this before, build automatically is recommended as pretty much a go-to starting point for the model, because what's great about it is that it gives you right off the bat an analysis and it tells you which variables are the most predictive out of the entire list. And so I'm going to make a change here just for the current circumstances and then rebuild that model automatically. But looking at this, it might not immediately be obvious what you could improve about the process, but just peeking at the decile analysis, this looks great. It's able to pick out what is the most frequently defaulting 10% of your population, and it's actually pretty smooth after the fact. And so this kind of might be a bit of a curveball in terms of what, in terms of being a bad model, because it's not a bad model, but there are some factors that you might consider. So if you do look through each of these options, these included variables, you may start to notice that failed to graduate enters in as a pretty solid predictor of loan default. And then if you were to also look through this list, you would see that it's not the top predictor, but it is one of the top predictors below cumulative GPA. And so that I'll pause for a moment and just offer up maybe the thought of what something might be a reasonable call to action for the person who is building the model here. And I don't have there's no way to do an open text poll. So I'll just pause for a moment longer. By a moment, I obviously don't actually mean a full minute because I'm going to keep talking now. So when you go through, there are plenty of circumstances like this where you're building a model and there are multiple groups within your modeling sample. And so this isn't the most obvious circumstance, but if somebody fails to graduate, if you're thinking about loan default and trying to consider what are the behaviors of students, it's perhaps quite a natural and very believable expectation that students that fail to complete their degree will be influenced by very different factors than those that complete their degree. For multiple reasons. One, because they don't have the benefits of a completed degree or all of those that they're intended to confer, and they have, generally speaking, less loan debt, or hopefully less loan debt, because they've been in the college for a shorter period of time. So what is actually a good idea here, I would say, or at least worth exploring to try and improve your analysis, would be to filter and to build a model for just the graduates versus the non-graduates. And this gets back to the heterogeneous population point that I had mentioned during the actual PowerPoint, because there are two reasons that you might do this. One is for statistical reasons. If failed to graduate is a dividing category and they truly behave very differently on a statistically significant level, the other reason might actually just be sort of a political one or an operational one, that you know you're going to treat these two groups differently, and so it would be better for you from an operational standpoint to have a model that would apply to each group. It's not always the best way to go. Some ways you can explore it, since this is the deep dive. Some ways that you could determine if this is merited on a statistical level is you could go to the Visualize tab and just make a quick mental note of some of the factors that are in the model, like EFC or cumulative GPA, because the big question is, do non-graduates and graduates have the same response to the included factors? So if you look at the EFC as an example, and then you view it by the failed to graduate flag, what kind of stands out to me, and I would forgive anybody who doesn't immediately see this, what kind of stands out to me is, first of all, that the people that completed their degree are defaulting at higher rates, which is counterintuitive, but again, it might have something to do with the fact that their loan debt is smaller. The other thing that stands out to me is that this relationship, just sort of looking at it visually, this looks like a negative slope. And let's see if I can do I don't think I can do like a mouse or a drawing thing. But but this relationship looks pretty moderately negative, whereas if I look at the people that did not complete their degree, this is kind of a flat line, certainly by comparison, which means that as EFC increases, while the people that completed their degree are then expected to default at lower rates as that EFC increases, the people who did not complete their degree are kind of defaulting at almost the same rate. And at that point, it makes you wonder if EFC even really does impact the people that failed to complete their degree. And this can happen quite frequently. So the way that you might respond to that is, as I had mentioned, go in and set a filter. And then I know that it's ones and zeros here, so I'll set a filter for people that did not complete their degree. And if I save this and I build automatically, then I'll see a very different looking decile analysis, but I'm confident that, so months enrolled, it actually, thinking about it, this makes complete sense that this would impact those that did not complete, because at that point, months enrolled basically refers to the size of their loan amount or their debt amount. And so this kind of makes a good amount of sense for this group of people. And actually, if we flip the filter, so I'll memorize this, non-completers. If I flip this filter around and I look at the people that did complete their degree, it'd be interesting to see if that enters in. Some of this, by the way, is improvised, so I'm not sure if that's going to enter in. Yeah, so it didn't enter in. But this is kind of interesting, though, because it's actually the people that did complete their degree, EFC did not enter in, and it was their age at enrollment and their cumulative GPA that entered in much more significantly. And so different variables entered for the different populations, and so by separating the population, it's quite likely that I've come up with a much more targeted investigation for each subgroup. I do completers model. I do want to make a caveat that it doesn't always make sense to separate your models. And so it's good to look at things like the percent concordance to see roughly how accurate your model was for the each subgroup as opposed to the group overall. And it's quite likely that, oh yeah, so I cleared the filter and then I build automatically. And now if I go ahead and look through, I actually see that the percent concordance, it actually increased if I use the overall model. So this kind of brings up an important point, is your main concern the overall prediction, trying to figure out what your loan default rate is on average, or is your goal trying to reach out and prevent people from graduating? Because this includes some factors that their effects are mixed between the two groups. So if I do this, it's going to be less targeted for somebody who's trying to reach out specifically to someone who did not complete versus did complete. And this is an ongoing investigation. It will always be a matter of asking around your executive team or figuring out from other stakeholders. But this is the first point that I wanted to make. So if anybody has any questions, definitely pass those in. But I was going to talk about the next example now. And I'll switch, I'll just go in order here. I'll go to enrollment. And I'll
James, I got a quick question for you.
Oh, yeah, absolutely.
On that modeling that you were just about to click on, that modeling tab, how do you select the variable to compare within your model? It seems like you just jump straight to build automatically. How do I know what variable I'm using to compare against the rest of the data set?
Yeah, so when I looked into, so when I saw the overall model, what I was looking at was which factors were influencing the group overall, things like cumulative GPA and EFC. And so my curiosity was to make sure that the two groups within the population, the two groups, it's just the two that I zeroed in on. There might be other individuals, so you may start to investigate, by STEM or non-STEM, or there might be other meaningful categories. But looking at those top predictors to make sure that they apply similarly, or they describe the same relationship for those two groups as was the criteria. But that's a good question, though, because a lot of times when people are curious about this, they don't know exactly where to go with it. So that's a great starting point. So, and yeah, and if there are other questions like that, like I said, that was a good one. So moving to enrollment, or the enrollment side of things as well, where a very similar question could certainly apply. I'll again begin by building automatically. And here is, I think I'll pause again to let people just take a quick peek and see what they think about the model. I'll hover through and just show you some of the relationships. So statistics is more likely to enroll. It is often the case, unfortunately, that different demographic groups have different enrollment rates at certain colleges. The days between the application and term start, the further in advance somebody applies, the less likely they are to enroll. If you are in state, you're more likely to enroll. Days between app and term start, again, just a different transformation, which is also a good point. Some people take this as a sign that maybe there's something going on with the model, or they are concerned about multicollinearity, but this is actually okay. It's the fact that it already enters in one form counts against it, but sometimes having both the linear term and a transformation allow it to smooth out the fit even more. That's a question that a lot of times people think the model is maybe in some way compromised by having it in there twice, but you'll notice that days between app and term start, it has, in one form, it has a negative coefficient, and then in another form, it has a positive coefficient. So it sort of acts to smooth itself out and come up with a more accurate representation. Distance from campus, SAT, bins, and then also institutional need grant. So hopefully everybody has their own hypothesis about how this model is performing. I would actually be reasonably confident that this model is good. Now, it relies on subject matter expertise because I am comfortable with all of these variables, but all of these are believable relationships. We know all of these things at the point in time that we're hoping to score someone for enrollment. So you know if they've announced that they are interested in a specific department, you know how far in advance they've applied, if they're in state, how far away they live, and any test scores. So those questions all having valid answers for this particular data set, and the decile analysis being reassuringly positive, this is probably a good model. There are some that see this decile analysis and aren't sure because there are deviations. For instance, this group should be more likely to enroll than the one after it, but this can sometimes happen just as a sort of standard error in the prediction versus the outcome. So even this is not overly concerning because all of these relationships are valid. Nothing, taking a peek at this, the chi-squared score, sometimes you'll notice that some have predictors that are really, really high, and high is not like 50 or more, it's way higher than any other variable in the model. So if this had a 200 and the highest after that was 26, that would be a potentially a negative sign because it just means that that variable is nearly certain to be predictive, whereas the others are, just quite likely. I add that caution because if you have a much larger record count, then the test scores do increase with some amount of proportion to your record count. So if I had 100,000 records, my chi-squared scores might be much higher, but that could also be quite normal. So these are things to check. The relationships are valid. None of these variables are collected after the fact. I might take issue with the SAT composite bins because it's quite likely that a 1 is less than a 2 and a 3, but these are probably meant to be categorical. And so this is one sign that I might want to go back to the statistics tab, and I might want to find those bins, set them as categorical, and then from there, I would probably want to rebuild my model to see how that goes. And it actually went ahead and added the SAT composite as a numeric field instead. So that's something to address, but outside of that, all of the signs are positive here. I'll circle back and maybe talk about some of the more advanced diagnostics there, but I think that what's really cool, I kind of tried to save the best for last. This is one of the coolest examples because, well, I mean, I'll see if people can guess. Let's see if we can use the questions pane as like an informal poll here. I will spoil it, and I will say that this model is not good, but if anybody can, maybe it's like a Jeopardy thing, if you can answer in the form of a question, then you can let me know, and I'll stop if I see somebody enter it in, or I'll just wait for a moment here. I'll kind of scroll through if that helps anybody. Keeping in mind, of course, the 3 points that I had brought up, that, you know, this is something to consider, this region, this, sounds silly as a presentation thing though, to say that you might want to look at the entire interface as a place to find things, but that's okay, it's out there, it's recorded. So I will start to answer it. Doesn't look like anybody's gotten it so far, but it's okay. Maybe some context will help. This is predicting cab fare. So the goal is, in theory, and maybe it's not overly obvious, but the goal is to, when you get in a cab, you know perhaps certain pieces of information to know how much it's going to cost you. Maybe you need to take your pennies out of your pocket and start to make change. So as you're going about that process, this model in theory is meant to help you to know how much that ride is going to cost you. And so this is the model that it came up with, and somebody did point out that in fact almost all of the variables did enter the model, and that is kind of impressive, and it does give me a bit of a sense that perhaps I'm not being strict enough in my p-value, or perhaps I'm not exploring as many variables as I could, because if everything enters, then what's quite likely to be the case is that I'm I don't know if anybody like mountain bikes or trail runs, but sometimes when you fall or when you have a small accident, it means that you're trying to push yourself even further and you just barely lose it. It's kind of the same, I guess, with modeling, where if you have a lot of variables that aren't entering into your model, you can certainly say that you're trying as many as you can. Yes, and somebody just got it. Somebody just got it in the questions. So what happened here for those eagle-eyed individuals out there is we're trying to predict cab fare, except that we're using as a variable fare per mile, and we also know the distance of the ride. And so you could pretty easily imagine that if you know these two things, if you know how much they're going to charge you per mile and you know how many miles you're going to go, then yeah, I could probably tell you how much it's going to cost. And so this is a great example of where the decile analysis paints a very, very pleasant picture. You're using a holdout sample, and so you're confident that it's not, you don't think it's overfitting. This is great news. Let me send this up the ladder and let's start making predictions. But when you go to score, you're going to get that unfortunate surprise of, oh, wait, I don't know how much they're going to charge. That's what this model is entirely meant for. And that's what exactly happened here. So the fix, it's actually quite simple. And this is, I believe, this is actually kind of a combination of a surrogate variable and anachronistic. So the fare is not entirely dictated by the distance. It's, delays and traffic might contribute to it, but it's definitely between the two, it's standing in for the actual outcome. So what you would want to do is go back and say fare per mile, exclude that. I happened to know that that was a field that I calculated because I wanted to try predicting fare per mile instead of overall fare. But if I rebuild this model, then you have other factors like what season is it, what's the consumer price index, distance of ride. Arguably, you might still include that because you can reasonably expect that if you're going for a longer ride, it's going to cost more. But so anyway, that really helps. Year of ride, this is another thing that often comes up with people. This is definitely a sign of a very challenged model. And if that's not clear to everybody immediately, if you could kind of imagine it, if you were looking this year to score your taxi ride or a set of taxi rides to predict overall fare collected, it's never going to be 2012. It's never going to be 2009. It's always going to be this year. And so if you're looking at historical data, it's actually really, really common that a previous cohort will come in as a flag or admission cycle or something along those lines. And so this is something you can account for. And actually, it is kind of accounted for through the consumer price index. This rises typically with the years. And so this is still very strongly related, but we don't want to use it as a predictor. So that is a bad thing, but this model is definitely working its way towards being a lot better. And there might be others, but I don't want to get too bogged down in all of the fine details. I do want to pause. I've been going quite at length. Anyone who's had an actual training session with me knows that this is even kind of a restrained version. I do get carried away in Vera Predict. I'll pause for questions. Does anybody have any specifically?
James, I got another quick question for you.
Sure.
How does Vera Predict know the type of regression analysis to run? I know that being, a binary variable outcome versus a continuous variable outcome is necessary, but when you're building automatically, how does the program know which one to choose?
Yeah, that's a great question, and it's something that a lot of people may not immediately even realize that there are different types, but especially as this helps anyone who is explaining their model to a team of stakeholders or to some collaborators, for instance. The reason, it depends on your outcome. Sorry, I'll cut to the chase here. So if it sees that what you're trying to predict, your fare amount, is a continuous field, then automatically Vera Predict will go ahead and actually use the statistical modeling method that is suited to continuous variables, which is ordinary least squares. And then additionally, and actually we do get this question a lot about people that are trying to write up reports and things to talk about what method was used. If we have a variable like enrollment, as an example, then it will know to use binary logistic regression. And the difference is that it outputs either a score or basically a percent likelihood. And logistic, as most people may know, that results in a 0 to 100% likelihood, and ordinary least squares outputs a continuous field, something like a 2.3 or 7.9 or something like that. And if there aren't any other questions, I can actually move to like a form of wrap up as well. So maybe I'll do that actually. Maybe I'll pull up the slide deck here and I'll bring up some things that I was going to mention earlier, or maybe just offer up a set of takeaways so that people can be confident as they move forward and build their own models. Yeah, okay. So once again, I did want to remind people that we have reporting coming up. We have other webinars coming up. But before I hand things back over to Alex, I did also want to I guess, identify that you can get a copy of these slides after the fact, and so I covered a lot of material that may have sort of meshed together. But maybe one of the biggest points that I can emphasize is that probably the most effective way to know if the model is good is to review the variables that are actually inside of it. And when you look at them, to make sure that these are all things that are available at the time that you plan to score. I think that that's the most common way that people run into issues, is they build an enrollment model that accidentally uses orientation data as an example, and then they find that they actually can't apply it when they want to, or they have to build a new variable, a new model. The other possibly more important factor is when you do build it, the subject matter expertise is entirely invaluable. So when you go through, if you don't understand a relationship, a great example might be something like this. If I'm building a model because somebody needs me to, or somebody else in the organization wanted me to dig into why cab fares are increasing or something along those lines, if I see CPI and I don't know what this is, I think this should go without saying, but better than handing off the model and saying, well, here you go, there's this thing called CPI that's really predictive, as well as the distance of the ride. If you know it, then this might be indicative of something that you can dig further into, and you can really start to investigate the causes. So actually talking about the model in a second set of eyes is critical. And that second set of eyes, as I was preparing for this presentation, actually found quite a few typos that I had put into the slides. So even on non-modeling projects, it's important. So hopefully everybody feels more comfortable approaching a model, knowing what to look for, even in the case that you don't know exactly how to resolve it, or exactly how impactful it will be on your final model. Now you can see it, hopefully. Now you can potentially do something about it, or you can talk to another person on your team, or can certainly reach out to us to dig into what that issue might be. So I'll turn things back over to Alex, and I will say thank you all once again.
Thanks, James. And thanks everyone for taking the time to visit with us today and to learn more about more of a granular view on how to see if the model is the best fit or not. We do have a few minutes. Any wrap-up questions if people have, feel free to go ahead and type them into the questions panel. I'm going to give people a minute or two to get those in if there are any. And while those questions come in, or if any do come in, I do want to highlight that we do have upcoming webinars. We've got a upcoming deep dive. Again, those are targeted a lot toward our existing customer base, but our next one is on reporting in Vera Construct. I believe John is the one who's going to be spearheading that. And then we also have another webinar that comes out on October 18th, and that's 5 critical factors for your prospect enrollment modeling. So again, something that's geared more toward the higher education crowd. It looks like we do have a question that just came in. James, I know that you're standing by, but can you briefly describe what the variable contributions and model fit statistics mean? It's the bottom left box in the interface.
Absolutely. And so, yeah, so I actually had it pulled up there. The percent model contribution, it tends to, for me anyway, I recommend it as an informational or model summary metric. So what it indicates in a nutshell is how much of the overall variation in the model each variable individually accounted for. So if you're looking at this, the way to interpret this is distance of ride between its multiple terms. Sometimes throws people. It contributed here roughly 11% and here roughly 31%. So overall, 42% of what made any one record different from the next was contributed, or was attributed to the distance of the ride. And so it kind of ends up being this operational way of explaining, what's really making the difference between one record and the next. And then CPI, for instance, is the next. Actually, it's more significant ultimately than the distance of ride. It's contributing just about 60 or 53% there. How it's actually made up is a combination of the standard error of the actual variable and I believe it is the coefficient. I can get back to you on that as well, but it's a combination of how much that variable tends to move around and how much of a contribution it makes. And so you might see something like CPI with a very small coefficient actually have a pretty significant impact because it can move so widely in terms of its actual values. So hopefully that helps.
Thanks, James. We still have a few more minutes if any lingering questions need to be asked. And again, while we're waiting for some of those to come in, we do offer free and unlimited training and support to anyone with a current Vera Predict license. So if you have any questions in the future, feel free to reach out to us via email at support@rapidinsight.com, as well as our phone number. So we'd be happy to follow up with any case-specific questions for a specific model you might be working on, or any general questions relating to statistical modeling. So with that being said, we're going to wrap things up and we're going to say goodbye and thank you very much for joining us for today's deep dive webinar.